All right, how my mathletes doing today? This is Mr. Muscarella coming at you, and we're going to take a look at Super FRQ question 5, part B. Not part B, part D. We already did part B. That was another video. So here we are, Super FRQ question 5D. Now, in this problem, we're being asked to find the absolute max and absolute min values of G and the X values they occur at on the closed interval -5 to 5. Now, anytime you're being asked for the absolute max or absolute min, you have to know that that means you want your Y values, that occurs at. It's not the X value, it's the Y value. However, this question also says and the X values that occur at. So we're going to take a look at both the X and the Y values, but if it didn't have that other piece on there that said and the Y value or X values they occur at, we would only give the Y value answer. That's all we want. So let's go ahead and get after this. Now our function G is defined by the integral from 1 to x of f of t dt. So our function G of x is that integral, and we've already done the groundwork for a lot of this in part A. Now, when you go to find the absolute max and min, this is the case where you have to test the endpoints. For a relative max or min, you don't have to worry about endpoints. Absolute max and min, yes, you do. So here we go, team endpoint. So on team endpoint, we're going to have the values of g of 5 and g of -5. And we did these already in part A, so I'll refer you to that video. But we would have the integral from 1 to 5 of f of t dt, and that came up with a value of, I think it was 3 pi over 2. Oh, no, that's g of -5. G of 5 has a value of 5 halves. So 5 over 2, and then our integral from 1 to -5 of f of t dt, that came up with our value of 3 pi over 2. So both of those came from part A, right? But you do have to test the endpoints, and that's why part A, that's why we had you do that in part A, because you're going to need it later on. So just as a reminder, if you're trying to find an absolute max or absolute min, you always test the endpoints. And then you also test for any sign changes on the inside, which in this case, because we're given a graph of our function, we would look for the zeros. So where are zeros? Well, we've got a 0 right here at x equals -3, another 0 right here at x equals 1, and finally over here at x equals 4. So now we're going to test each one of those x values as well. All right, next we're going to go ahead and take a look at our integral of our g value of -3. So for here, we're going to have our integral from 1 to -3 of f of t dt. Now we already know that the value of the area for that spot, the semicircle that's right here, so let's just kind of shade this in. I already found that area before, and we knew that area was just 2 pi. But because that area is underneath, because that region is underneath the x-axis, that would have to be a -2 pi. Normally, we'd be good there, but notice your limits of integration. We're going from right, we're starting at 1, and we're moving in a left direction. So even though that area would be -2 pi, because we're going in a right direction, we're starting with a lower limit at 1, and we're rolling out to the left, we would actually have to take the opposite of that sign. So the opposite of -2 pi, of course, would just be +2 pi. So the value for g of -3 is 2 pi. Now let's take a look at our next x-intercept right here, and that's at 1. So g of 1, now this one should be a very straightforward, old-fashioned rule that you guys have memorized here. So anytime you have an integral with the same upper and lower limits of integration, you know that you should know the value of that's always going to be 0. Always, always, always. So we're good there. Well, a couple exceptions when you've got your improper integrals, but more on that later. Lastly, we've got to test our x value of 4. And we already did this part too, and that was the triangle that's above the x-axis from 1 to 4. So we knew that base was 3, the height was 2, and when we did that calculation, the integral from 1 to 4 of f of t dt, that we came up with an answer of 3. So that triangle had an area of 3, so we're good there. We've got all the pieces we need. So now we just got to do a little analysis. For an absolute max, I want the biggest y value. So if I look at all my answers here that I just calculated, 5 halves, 3 pi over 2 from team endpoint, 2 pi, 0, and 3, my biggest value, the biggest value that we have, of course, is going to be 2 pi. So that's going to be my max right here. Now my minimum, if I look at all my values, my min is going to be 0. So my minimum value is 0, and my maximum value, my absolute max, is going to be 2 pi. Now, I could say this a couple of different ways. Option 1, we could say G has an absolute max of 2 pi at x equals -3 and an absolute minimum of 0 at x equals 1. So that's one option. Another option I want to offer to you is just identifying the point, because if you do that, if you list as an xy value, you've covered both of those. So there's your other option for answering that question. You could say there's an absolute max at -3, 2 pi, and there's an absolute min at 1, 0. And that takes care of both pieces of this question. However, if the question did not have that other part, then you would just say there's an absolute max of 2 pi. There'd be an absolute minimum of 0, and that's it. You don't have to identify the x value. If you do, awesome. It's better to have it and not need it than need it and wish you had it. So that would be worth your points there, showing your work, showing your setup, showing your answers, and then of course you're justifying. So make sure you do your justifying correctly. All right, thanks so much for watching this video. Appreciate it. You guys have an awesome day. Peace out, Mathlete.